In this demo, we'll look at migrating your containerized application, which is a Blogger application from Amazon EKS Cloud to Google GKE Cloud. And then we'll also set up a DR environment within Google GKE Cloud, and we'll do all this using RackWare Swift as a solution. The initial migration from Amazon to Google Clouds will be lift and shift kind of migration. So this demo is assuming that you want to decommission your source environment, and this also demonstrates that how you can set up a DR policy to do recurring things, and how DR set up within Google GK Cloud. Now let's look at our environments. First, we look at the source environment, which is Amazon EKS. Now we are using Amazon EKS in the US East region, and we'll keep the same region for our new production in Google GK. Before we jump to the target environment, let me show around the source environment. So here's the EKS production demo cluster, which is a production cluster for this demo. And since Amazon doesn't provide any native dashboard, so I have deployed a dashboard here. So you can look at it, and let me log into this dashboard. So I have created a test blogger app namespace where our blogger application is running, and you can see it's using bunch of stateful set, replica sets, services, microservices, config, max secrets. It has pretty much all objects. And in fact, if you look at it, it's using deployment for the front end of application, which is WordPress, and it's also using a stateful set for the backend database. So it demonstrates both stateful and stateless application migration as well as DR. Also, before we jump to next part, here's the something interesting. It's using PVC's persistent volume claims, which are your volumes within Kubernetes of GP2 storage, which is Amazon EBS storage. And this demo will also show that how you can convert your storage from Amazon EBS to Google GKE and block storage in Google. And interestingly, this also will demonstrate how you get an option to choose the storage in Google side, available options in your target. And both sides, like especially Amazon EBS, which is your source storage, it does not support snapshots. It's using non-CSI volumes, and even their CSI volumes don't yet support snapshot. So this will show that how Swift will still allow you to replicate these storages which don't support snapshot. Swift will essentially use the storage layer and snapshots at that level to allow migration of these applications as well as set up a DR. Now let's look at the target GKE. Here are the two clusters created. We have a production and DR cluster. Production cluster is set up in the same region as US East, which is our current region for the Amazon cluster too. And our DR clusters obviously is in another region for the disaster purpose and the compliance reasons. It's running in the Asia region. It's Asia South 1 region, which is essentially Mumbai region. And I have deployed dashboards for these two. This is the production cluster, and I have created a namespace there to just to demonstrates, like it doesn't have anything running. The secrets and config max you see here are created by this dashboard. There is one secret which I have pre-created, which is a image pull secret to point to the location or the image registry, container image registry, where our transient agent image is located. We call it a transient RackWare agent image try. Essentially, during a sync, instance of this try is created. We call it a tripod, and Swift will orchestrate that. And in the new release, this is also automated, so you don't have to pre-create this. Though optionally you can to override the sync behavior, but Swift can now replicate registries too. Here's our DR dashboard, and obviously nothing is running in both namespaces right now. And here's the Swift instance. Obviously, Swift is going to do migration as well as then will be reused or repurposed to do the DR within GK. So what we recommend for DR is generally you set up your Swift in the DR region. In this case, which will be like a Mumbai region in the Asia, because if you lose your source site for any reason, disaster happens, you fail over, then you don't want to lose Swift because Swift will contain backups. So you may want to restore anything from there You can in fact like resync from Swift if you want. So Swift will make sure as part of failover everything comes up. So it's located in the US region. Now, there is nothing special. The only special thing here is I added a 50 GB volume. I call it like back backup volume because this is where the Blogger backups essentially this is where your backups will be stored. It's a 60 GB in size and you can add more than one volume. Swift supports essentially any block storages. So this is a CentOS template, so any block storage which CentOS understands you can use that under a Swift to do backups, and shortly you'll also get an option to do backups under object storage for Google. You can also do long-term backups there, and within Swift we'll see like how you can manage the storage under different logical pools. Now let's start our migrations. Here's the Swift dashboard. So this is the same IP as this instance. You can see the IP here under networking. So 223.33 and the same IP. So you just log into the Swift. Now, when you install Swift on CentOS or Red Hat or Oracle Linux template, during initial installation, it will give you choice to set up initial password for the admin user. And once you log in with this admin user and the initial password set for it, you can create more users. Swift supports multi-tenancy. So I'm just logging with the initial password I set up during the Swift installation. Now it landed us on the container clusters page because there is no cluster added yet. Let's add all three clusters here. So it's our SIP cluster, which is located in now Amazon EKS. Let's add that. So here are the details for the source production cluster. You just need the name in the EKS cluster, and then of course the friendly name, which is what SIP will refer to, and some cloud credentials. So I'll just add it. So cluster is added, which is EKS cluster. Let's add GKE clusters. Input of GKE cluster almost remains the same. So we have name given here, GKE production, which is friendly name, and then we just give the actual cluster name along with some cloud credentials, which is basically private key file as well as whether the cluster is regional or zonal. Now this is a regional cluster, and some other credentials like where our try image is located and the image pool secret for that. Let's add this. So the cluster is added. Next, add the next last cluster, which is GKE DR. Now this is also a regional cluster. It's located in the Mumbai region, this being a DR, and this also needs the similar credentials options. The clusters are added, and if you look at it, like it will show us all the namespaces, everything is discovered and analyzed. It will rediscover it whenever we sync to find like what all is running. So you can see that in the blogger app namespace nothing is running, while in the EKS production if you go to the same namespace we'll see everything is running, like it shows the pod and you can actually look at different for example volumes. It will show everything including all the labels. So everything is discovered. Now let's start the replications. So we'll go to the sync administration, all replications. No sync has started. We'll start the application replication now. And this will be a pass-through sync. So this will not need any storage. So if you noted, like we haven't added storage yet in the Swift. So though it's attached to the Swift, so Swift is not going to use that. So essentially in pass-through sync, Swift will essentially pull data from the source and pass it to the target host. So it's there is no store and forward. It's like pass through sync. Swift will only store the Kubernetes objects. This mode is made for migrations. So let's start the migration. So this will be our lift and shift migration. Now you can do this sync recurring fashion. You can also create a policy for this, and this is pretty useful if you are doing say recurring syncs during a cutover window. So I'll select the namespace on both sides, which I want to replicate. Now you can selectively specify what you want to sync. So if you select, for example, service, and specific service instance, it's going to find the dependencies for that service object. So for this demo, I'll select all objects in the namespace. It's going to find the dependency and sync everything. Also, here's something interesting. So here you will get an option to choose what storage class you want to use for the target. So what your storage is available on the target, in this case, all the Google storage classes available. So you'll be able to choose between them. So I'm just going to go with the standard storage, which is default as well. And then I'll also select a location where the volumes will be placed. Now, in these details, you see these are our try or transient pod details, and here you can basically specify what kind of microservice IP you will choose. So I don't have any special connectivity between Swift to the source cloud or the target cloud, even though Swift is running in the same region. There are no special connectivity setup, though that's not an issue because it will use two ports to talk to microservice on both sides of clusters, and that though both ports use VPN grade encryption. So even if you are doing this over WAN, like in this demo case, it's everything is safe and secure. So I'm going to ask it to do like a load balancer service on both sides, and I'll just specify two ports from the service port range. Now you can ask it to the auto select ports if you have like all service port range whitelisted in the intermediate firewalls. I haven't, but this should be okay because it's going to uh, it's going to basically open these ports as part of load balancer service. I will give it this job name, that initial replication. Also, here are some advanced options. You can select pre-post scripts, also determine the resources our transient pod will use. You can also change the image registry endpoints, map them if they change between two environments. Typically they will. In this case, it doesn't because we are using all the open source public registries. You can also specify the volumes for exclude or include, and also change the service types or change ports. Just to demonstrate this configuration, I'm just gonna change the node ports of the front end service. So I'll just change ports from, say, pick the post port, and I'm say randomize this port. Just pick any port available on the target side. We can specify the specific ports too. So randomize, and let's start this job. It started rediscovering both sides of cluster. It will find the latest dependencies of the selected application or objects and replicate everything, including volumes. And we should see that coming up here in the target namespace as well. Let's go to the Blogger app. We'll start seeing pods coming up here shortly. And we can see that transient pod is created now. Also, the volumes are created here, and they are now using the Google Block Storage and standard storage class. Also, let's look at the source application, and we'll see that it does not have any impact. It's still running. It's a blogging application, and let's look at it. Let's go to the services, and then we'll just look at the endpoints. Here's the public IP of the front end, and it's a simple blogging website. You can see there is a test page created, and it's up. There is no impact whatsoever, and the replication is still running now. So sync is almost done. We can look at the live checkpoints here. As the sync progresses, it will show us nice statistics. Okay, sync finish. Let's look at the stats, how much data was transferred. So you can see actual data transferred. Also, you can see the volume level summary, how much data was transferred for each volume, how many volumes were transferred. So it will show nice statistics. Also show like, what kind of objects it transferred. Okay, let's look at the target application. So I'll go to the native dashboard. So you can see it replicated entire environment just like source. So it has stateful sets as well as deployment as well as microservices, everything up. And it retained the service type. We didn't change that. So we got the public IP, and let's connect to the IP. And before we connect to the IP, let's look at the volumes. So you can see the volumes contain data now. And these volumes will not be recreated if you resync. They will be resynced instead. Let's connect to the application, and as expected our application is up, and we can see that our test page is also up. Now let's go ahead and set up a DR now. Now at this stage, you don't have to just do one sync. You can actually do recurring syncs. You can create a DR policy for pass-through sync type and set up a recurring syncs. And this is useful, let's say, if you are doing recurring syncs during your cutover window for lift and shift migrations. So this kind of demonstrates so far the migration use case. Now we'll jump to the DR part of it. Now let's set up a DR within our GKE clusters. So I'll go to, let's first add storage. So I'll go to storage pools. Let's add the 60 GB block storage which we had added to the our Swift instance, and we'll use that. So if you see here, we have 60 GB volume added to the Swift, which is a data volume. Let's add that to the storage pool. I'll call it a Blogger app backups backup pool. And you can look at the devices. If you're not sure, you can always connect to the Swift server and cross check which partition you want. Though this wizard will also warn you if you try to use volume which has a file system on it. And let's add the device and let's create a pool. So pool is created. At this stage, if you expand, look at it, usage is almost zero because we haven't done any captures yet. Now let's create a DR policy to do recurring syncs. For this example, I'll just create a 30-minute policy, but you can create continuous sync policy or any 1 minute, 2-minute policy, whatever you want. So I'll call it 30-minute policy. Now stage one and stage two stands for data pull and push. So stage one essentially means it will pull the data volume and image registry objects from the source cluster to the SIP storage, and then stage two means like it will push that to the target cluster. Now stage one and stage two can be done independently. You can also create stage one only policy, so wherein you only SIP will do backups in a storage pool, not restore anything. But we want to do it back to back. As soon as stage one finishes, we want stage two to run. So you can also give the exclude window for both. So what I'm gonna do is I'll just select the 30-minute frequency. Don't need any exclude window, and I want stage two to happen right after stage one finishes. I'll also give my email alert. So I'll add my email, and you get option to only get alerted if something fails. But I want everything, so I'll just specify that. You can also specify pre-post scripts or pre-post YAMLs to be run or applied before and after DR syncs. I don't need that, so I'm just going to go ahead and create the policy. So policy is created. Now let's apply the policy. Now, typically you can directly apply the policy at this stage and let policy drive all syncs. But what we typically recommend is like you do first stage one and stage two sync explicitly, test your application, make sure everything is okay, all the configurations you want in sync are okay, and you can just convert those jobs into DR policy. So inherit that configuration into DR policy as part of policy apply. So which is what we'll do. So I'll go back to all replications and start a new stage one sync. Now, before starting stage one sync, let's do some changes on our new source application, which is running now in the GKE cluster. Log into the admin interface and add some test pages. Go to the pages. I'll add a sample page here. Now, this page is added only on the new production, which is running in JK. So we'll see this page coming up in the DR side as well, because Swift will replicate everything. Okay, let's start our stage one sync now. So inputs remain almost the same. So I specified the port here, just like we did in pass-through syncs, and which is for our transient pod. And I specified the backup name, where everything like image, objects, everything will be backed up under that name, under our storage pool, which we just added. And I'm asking it to just back up into the SWIFT storage pool from the source or production, which is our new production. I gave it the initial stage one as a job name. Just do this. So job start, it's going to rediscover and find the new dependencies from the new production and then back everything up. Stage one sync finish. So at this stage, we have entire GK production cluster backed up, the required application namespace backed up. And we should be able to see that use is now under storage pool. So if we go to the storage pool, of course, application is small and Swift will do a lot of compression under this pool. So we will see a lot less users than actual application is, and we can see the captured image group and the actual users there. So you see two volumes captured along with all the objects and all. So let's now go back and we can also check the source application, which should still be in the production. There was no impact whatsoever. We have two pages. Let's do the stage to sync now, and we'll restore this application to the target cluster, which is our new DR cluster, and then we'll create a recurring sync policy for that. Go stage to sync. We'll select the new backup name, and we want to restore it to the GKE DR demo, which is target cluster, and we'll restore it to the same blogger app namespace. Currently, it doesn't have anything running. So let's also pick a zone. It doesn't matter what zone you pick, and then we'll choose the same storage default. So you can change that now. You have option to do that. I'll select the ports. And just like in pass-through syncs we did initially, you can actually change the ports, and let me do that. So while restoring, I'm just gonna ask it to change the node ports again, just to demonstrate that you can do that as part of recurring syncs too, because when you apply a policy, it's gonna reuse the same configuration. I'm gonna keep it the same type, which is load balancer, so that we can access it because we don't have any special access setup here. I'm just gonna change the node ports to some random ports. And let's start it, and I called it initial stage to job. It's gonna rediscover the cluster and then look at if volumes are created. Now this is the first sync, so it's gonna create the volumes and we should see the users on the target side. And after this sync finishes, we should see application up on the target. At this stage, we should see the target cluster launching a pod and a transient service, which is up now. Okay, stage two sync finished, and as before, we can see all the statistics like how many objects it restored, and also the nice checkpoints. Also, all the sync statistics like how many volumes it replicated, per volume summary, etc. Now let's verify the target application. We can see on the target dashboard that everything is up. All the config maps, create services, all the objects basically are restored with all the correct labels. And here's our application. It got the external IP because we kept it as a load balancer type. And we can see that both the pages we created are up. Now, before we put these jobs, now at this stage, basically we have everything validated. Now we are ready to put the jobs into a sync policy, which is a recurring sync policy. But before we do that, let's do some changes on the source cluster. I'm just gonna do add a page here on the source cluster on source application. I created a test page here to which demonstrates the delta sync, because as soon as we apply DR policy, it's going to run that run a sync, and we can see that third page is up now. So let's go ahead and put the two sync jobs into a DR policy. So we'll go back to our DR policy. We'll say like, okay, go ahead and apply. It's a stage 1 to policy. We'll ask it to start immediately, and then we'll pick the jobs now. So I selected the initial stage 1 and stage 2 jobs, which we just did. I also specified the source configuration, and this is used in case of fallback or failback syncs. So in case you use the policy to failover for either testing or real failover, and then you want to fail back, SIP can help you restore the source application too. If you have rebuilt that application, SIP can help restore all the data, because during drill or during your actual DR failover, your target application will be into your production. So I just applied. It's going to immediately start the sync. You can see the policy is up. To go to the syncs, we'll see a new sync. Okay, sync has started. It started backing up again. Stage 1 finished. Now stage 2 sync should start at any moment. Okay, stage 2 sync started. Okay, stage 2 finished as well. If you go to all replications, we can see 5 syncs. The initial pass-through syncs, which we use to move application from Amazon EKS to Google GKE production, and then two stage 1 and stage 2 syncs we did manually to validate that sync config is okay. And then we put that under DR policy and policy did one sync. Now policy is not going to run for another 30 minutes. Now let's look at the source application. There should not be any impact whatsoever. So source should still be running. This is the GKE production cluster. If we connect, we can see everything is up just fine. Now let's look at the target application as well, which is this is our GKE DR cluster. And if we go to services, everything is up after stage testing, and all the labels, everything is properly set up. And let's click on this, and we already see that our page is up. We can also log into this using our source side credentials. And we can see that everything is just fine. Now let's assume that DR event happens and you lose your source and you want to fail over now. Now since Swift is running into your DR region, Swift should be available. So you'll go to DR policies and you'll click on this. And now you will probably do this also for the DR drill syncs or drill failover wherever you want to do testing. So you can actually do that too. So you just click on this failover. Now in this case it's a drill. We want to failover for testing. We want to replicate. We want to basically failover all. Now if it has outstanding changes, it's gonna sync those using stage 2 sync. Like if there are any stage 1 syncs which completed, which haven't been replicated back to target side, it will replicate them back as part of failover. And in this case, it's going to immediately fail over because there are no outstanding changes and target application is up to date with the latest backup. But you can force stage to sync. So it should immediately like a failed over. Similarly, like you can at this stage go to the target application, do your testing, like do all validations. If it and then you can fail back. Now, in case of real fail back or real failover, where actually you lost your source, what's going to happen is by default when you fail back, it's going to sync back to the source. You can skip it. Similarly, in case of drill, it's not going to sync by default to the source because it knows and it understands it's for drill. So if production is still up, it should not touch it. But if for some reason you want to force reverse sync, you can sync that here. So similarly, like fallback is going to immediately complete here. So that's what we wanted to show in this demo. We basically looked at the Amazon EKS to GKE migration, and then we set up a DR within GKE. If you have any further questions, please reach out to us at support@rackware.com. Thank you.